Welcome, everyone. Today, we'll dive into a Capture the Flag CTF challenge based on a rock, paper, scissors game. We'll explore how the game works, analyze the bot's strategy, and develop a method to outsmart it. This session is designed for high schoolers and undergrads with an interest in cybersecurity and programming. Here's our roadmap for today. We'll start by understanding the challenge and the game mechanics. Then, we'll analyze how the bot operates. After that, we'll develop an exploit and walk through the provided exploit script. The challenge is to play rock, paper, scissors against a bot. Our goal is to win 20 more rounds than the bot before reaching 100 rounds. If we achieve this, the bot reveals a secret flag, which is the goal of the CTF challenge. The game follows the classic rock, paper, scissors rules. You input your choice using R, P, or S. After each round, the bot tells you the outcome, whether you won, lost, or tied. By playing the game a few times, we notice that the bot doesn't always act randomly. It makes comments that suggest it's adjusting its strategy. We can identify 3 distinct phases in the bot's behavior based on the number of wins we have. In phase 1, before we win our first round, the bot plays randomly. Our goal here is simple: win a round to move the bot into the next phase. In phase 2, the bot starts copying our last move. To exploit this, we can select a throw that beats what we played in the previous round, since we know the bot will copy it. Phase 3 is where it gets interesting. The bot now uses the history of both your and its moves to predict your next move. It looks for patterns and adjusts accordingly, making it tougher to win. To fully understand the bot's strategy, we need to look at the source code. The getComputerThrow function determines the bot's move. Variables like player wins and mode help us track which phase the bot is in. This function shows the bot's decision-making process. If player wins is 0, it returns a random throw. If player wins is less than 5, it returns your last throw. After that, it enters phase 3, where it uses more complex logic to predict your move. In phase 2, since the bot copies our last move, we can always play the move that beats our previous move. For example, if we played rock last, we'll now play paper because the bot will play rock. In phase 3, the bot examines past rounds to predict our next move. It looks for instances where the combination of our move and its move has occurred before and assumes we'll follow the same pattern. To exploit phase 3, we can manipulate the history that the bot relies on. By feeding it specific patterns, we can influence its prediction and make it play a move that we can beat. An exploit script has been provided to automate this process. It interacts with the game, sending specific throws to outsmart the bot. The script is written in Python and uses the Poon library for handling the process. First, we start the process and define helper functions. RecvBot reads the bot's messages until a certain point, and throw sends our move to the bot. We loop until the bot's message indicates we've moved to phase 2 when it mentions smart. During this phase, we keep throwing rock to get our first win. In phase 2, we play the move that beats our last move. We continue this pattern to accumulate wins until we reach phase 3. For phase 3, we use a predefined sequence of throws to manipulate the bot's history. We repeat this sequence to consistently beat the bot until we meet the win condition. Once we've met the win condition, the bot outputs a coded message and then displays the flag. This means we've successfully exploited the bot and completed the challenge. In conclusion, by analyzing and understanding the bot's strategy, we were able to develop an effective exploit. Manipulating patterns is a powerful technique against bots that rely on historical data. Automation with scripting makes exploiting such challenges more manageable. If you're interested in learning more, I encourage you to explore other CTF challenges. Delving into game theory and predictive modeling can provide deeper insights. Also, continue practicing your scripting and automation skills. They're incredibly valuable in cybersecurity. Thank you all for participating. I hope you found this session informative and engaging. Feel free to reach out if you have any more questions or need resources.